The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I'm going to work through problem number 20 for Physics 2020 Midterm Exam 1, year 2010. And this problem says, what net force is needed to bring a 1,000 kilogram car to rest from 90 kilometers per hour in a time of 5.0 seconds? All right, so the problem is asking us what net force. And we know that force is defined by, is equal to mass times acceleration, or mass times the acceleration due to gravity if we're talking about weight force. Since we're talking about a car that's moving on the ground, we're going to use this part. Alright, and we know that the mass is equal to 1,000 kilograms, but we don't know the acceleration, so we can't use this formula directly. Somehow we need to calculate the acceleration. So can we do that given the information in this problem? The obvious answer is yes. And so how do we do that? Well, we know that the car is initially traveling at 90 kilometers per hour, and we know that the final velocity has to be 0 because we want to bring it to rest. Okay, so that's 0 kilometers per hour. And we know that the time of the duration for the time between when the car is moving to when we bring it to rest is 5.0 seconds. And if you look at your formula sheet for this midterm exam, you'll see several expressions for acceleration, but basically what we're trying to determine is the average acceleration. Acceleration is actually going to be a deceleration, right? So we're slowing the car down, and we're trying to find that average deceleration in that given period of time. And we know that acceleration is defined at the change in velocity over the change in time. So that's the final velocity minus the initial velocity over the final time minus the initial time. Okay, and so one thing that we have to be careful of are units. So let's look at the answers. All the answers are given in units of newtons. Okay, so newtons is a unit of force, and that unit is kilograms meters per second squared. All right, so if the answers are going to be in newtons, we need kilograms, which we have. All right, we also need meters, but we don't have that. We have kilometers, and we need seconds squared, but we don't have that. We have hours. So we need to convert kilometers, and we need to convert hours. We need to convert our velocities to meters per second squared. So let's do that. We don't need to worry about, so for the final velocity, if it's 0, it's going to be 0 meters per second. Okay? So all we need to do is worry about the initial velocity, which is 90 kilometers per hour. And we know that in 1 hour, there's 3,600 seconds, so the hours cancel out. And we know that in 1 kilometer, there's 1,000 meters, so those cancel out. And we're just left with meters per second, and that works out to be 25 meters per second. All right, so that's our initial velocity in meters per second. Going back to our equation for acceleration, so now that our acceleration is going to be our final velocity, which is 0 meters per second, minus our initial velocity, which is 25 meters per second, all right, divided by our time, So this is 0, so our final time is just 5.0 seconds, right? And so that our acceleration is just going to be minus 25 meters per second divided by 5 seconds. So acceleration is going to be minus 5 meters per second squared. Okay? And you'll see that it's negative because, as I said earlier, the acceleration is actually a deceleration. We're slowing the car down, so that's the reason why the sign is negative. So that indicates that the car is slowing down, an object is slowing down rather than speeding up. Okay? So now we know the mass, we know the acceleration, we can find the force. That's defined as the mass, which is 1,000 kilograms multiplied by a minus 5 meters per second squared. So the force is equal to negative 5,000 newtons. Okay, but it's asking us the net force. So the net force, basically, we just want the magnitude of the force. So that's just going to be 5,000 newtons. Okay, and so that is the solution to this problem.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.